Good morning to all. Today the name of the topic is scalability and elasticity in cloud computing. So we are going to discuss about capacity planning, in which we have to study about scalability, elasticity in cloud computing. How can we achieve scalability and elasticity in cloud computing? Now first we have to study about what is cloud elasticity. Basically, the elasticity refers to the ability of cloud to automatically expand or automatically compress the infrastructure resources on sudden up and down in the requirement so that the workload can be managed efficiently. It means if the cloud is, or if the cloud have cloud elasticity, it means we can add the resources or we can even drop out or delete the resources. It's completely depend upon your requirement. It means we can do the increment or decrement dynamically. If I feel that my resource demand is increasing, I can add it. Or if I feel that my resources are not demanded so much, I'm wasting my money and wasting the memory space, we can just delete it. It means if the cloud is have the property of cloud elasticity, it means we can add more resources, we can remove resources. When your business is sudden up or down, it can be done dynamically. It's not for a static purpose. Basically, cloud elasticity means we can add resources, we can remove resources dynamically. Dynamically means within the conditions, within the requirements. We don't need to wait. We just have to take the step on a time. This elasticity helps to minimize infrastructure cost. So I don't need to spend more cost on the resources which are not longer in a use. We just need to remove it. This is not applicable for all kinds of environment. Basically, cloud elasticity is not comfortable or friendly with the all type of or all kind of environments. It is only helpful to address only those scenarios where the resource requirement fluctuate up and down suddenly for a specific time internal. So when we are talking about static environment, in such case, we can't follow the cloud elasticity. Basically, cloud elasticity useful only those situations or only those scenarios when you feel that your resource requirement can increase or decrease dynamically. So cloud elasticity means we are comfortable or we are flexible enough to add more resources or to replace or delete unwanted resources dynamically, and it is only comfortable with a dynamic work environment. We cannot go for a cloud elasticity in case of static environment. So it is useful or even helpful in the situation when your resources sudden up and down. It is not quite practical to use where persistence resource infrastructure is required to handle the heavy workload. Basically, it is used for only those cases when we feel that we need our resources or we just need to drop or delete the resources on the dynamic basis. Nothing is fixed. Everything is dynamic, flexible. And it is most commonly used in pay-per-use public cloud services. So which type of service is it? It is a public cloud service, not a private cloud service, not a hybrid cloud service, not a community cloud service. It is what? It is public cloud service, and it's completely depend upon pay per use. So how much you pay, the more the services you will get. And where the IT managers are willing to pay only for the duration to which they consume the resources. So one of the advantage of using cloud elasticity is that we need to pay only for the time period for which I just want to use the resources. If I want to use the resources for 1 month, I just need to pay for 1 month. I don't need to pay for whole year, and I just want to use the resources only for 1 month. So it's completely depend upon your requirement. So cloud elasticity means we can add resources, we can remove resources according to the requirement, and your requirements are dynamic, changeable, not fixed, variable. Whereas it is only suitable or friendly with a dynamic environment. We cannot use cloud elasticity with a static environment where the requirements are fixed. So it is useful or it is workful in only a dynamic environment. And it's basically useful in the cases of when you feel that you have to add some resources, or you feel that in some situations you need to remove the resources, and it's completely depend upon pay per use. its cost is completely depend upon your usage. How much you use, you have to pay accordingly. And it comes under the category of public cloud service. So it is useful because we don't need to waste money for extra resources. I just need to pay according to my requirement or the time period on which I just want to use the resources. This is the one advantage of using cloud elasticity. Next is cloud elasticity versus cloud scalability. We have to learn about two terms, cloud elasticity and cloud scalability. There are many aspects of cloud computing where CEOs and IT managers should consider when deciding to add cloud services to their infrastructure. So not every infrastructure is following the cloud services, but it's completely depend upon the IT manager when he or she want to add cloud services to their business. Cost, security, performance, availability, reliability, these are the major areas that we have to focus on when we are going for cloud computing. Another condition that has been added to the list recently is cloud scalability and cloud elasticity. When any IT manager or when any organization decided to switch from normal services to cloud services, the factors that should be considered, one of is cost, second is security, performance, availability, reliability, and we have two more terms that we have to focus on, that is cloud scalability and cloud elasticity. Many have used these terms interchangeably, but they both terms are different. So first, you know the difference between cloud elasticity and cloud scalability. Before going for cloud computing, it is the responsibility of the organization or IT manager to know the difference between what is cloud elasticity, what is cloud scalability, how both terms are different to each other. Then we can choose a best for our organization. So it's IT manager responsibility to know the both terms very carefully, and then he or she have to decide for which they have to go for. They want, if they are going for to add resources or to delete resources dynamically, then he or she need to go for cloud elasticity, not for cloud scalability. So both terms are not same, they have a difference in their working. So before going for a cloud service, it is the responsibility of the IT organization to know that both terms and know the difference of both terms very carefully, then go for the implementation of. Now see scalability versus elasticity. The basic purpose of elasticity is to match the resources allocated with actual amount of resources needed at any given point in a time. So scalability means we have to match the request. It just match how many resources are allocated and how many resources are requested. Let us suppose I have put a request for 10 resources and only 8 resources are allocated to me. It means my request is not completed. I have to wait for two more resources. It means I can't just start my transaction with the incomplete resources. So first of all, what elasticity check? It checked how many resources allocated to you and how many resources are requested by you. Scalability handles the changing needs of application within the confines of the infrastructure via statically adding or moving the resources to meet application demand if needed. Now see, scalability also handles the need of application, but it's completely related with statics environment. You have to add or remove the resources when the demand arises, but this all be done statically, not dynamically. In most cases, this is handled by either we can go for a scaling up, that is called vertical scaling. We can go for scaling out, that is comes under the category of horizontal scaling. Scalability can be more smooth and targeted in nature. Then elasticity when it's come to size. When we have to work about the size of database or a size of files, then scalability is considered to be best as compared to elasticity. Common use cases where cloud elasticity work, its applications are e-commerce and retail, software as a service, mobile, DevOps, and other environments that have ever-changing demands on infrastructure services dynamically. Business that have predictable workload where capacity planning and performance are stable and have the ability to predict the constant workload or growth. Cloud scalability may be better cost saving choice. Now see the difference when we have some little bit prediction how many resources I need to add, how many resources I need to delete. In that case we have to go for scalability, something you know in advance. But cloud elasticity means I don't know anything in advance. I'm still working. I don't know how many resources I need to add or how many resources I need to delete. Everything should be done on a dynamically. Nothing is known in advance. But in case of scalability, some of the clues, some of the hints, you know how many resources you need to add or how many resources you need to delete. So in case of scalability, we know something in advance. We have some fixed criteria scenario regarding the sources allocation and deallocation. Whereas in case of elasticity, nothing is known, nothing is predictable. We just doing the work, keeping on the work, but how many resources we need to add, how many resources we need to delete, everything is done dynamically. So this is the difference between scalability and elasticity. Now see the example. Consider an online shopping site. We all know that in a festival seasons like Christmas or in a Diwali or on any other festival, in this period of time, the resources need spike up. In order to handle this kind of situations, we can go for cloud elasticity services rather than cloud scalability. Because in let us consider an example of Christmas. I don't know how many customers have to visit on my website during this festival seasons. So I don't have any prediction, don't have any single clue, don't have any single hint. So I don't go for scalability because it's depend upon the situation. Maybe I got a high lead on my website, or maybe I have a 0 likes or a lead on my website. So it's completely depend upon the interest and taste of the people, of the population. So it's not, nothing is predictable to me in advance. So let us suppose I'm working on an Amazon and someone is working on a Flipkart. Maybe Flipkart got highest lead on this festival, or nobody is going to access for Amazon. So nothing is predictable. If we know little bit know in advance, then we have to go for a scalability. But if we don't have any clue in advance or nothing is predictable, we have to go for elasticity. So elasticity is the ability to grow or shrink infrastructure resources dynamically as needed to adapt to workload changes in an automatic manner, maximizing the use of resources. As we have discussed earlier, elasticity means we can add resources. It means we can grow the resources, we can shrink the resources dynamically. Nothing is defined or nothing is a known in advance, whether I have to go for a shrinking of resources or we have to go for a growing of resources. So if we are going for elasticity, we just make dynamic changes in an automatic manner. By using elasticity, we can maximizing the use of resources. This can result in saving the cost. Yes, it's completely true. When we are doing everything dynamically or in an automatic manner, definitely we are saving infrastructure cost. So as we have already discussed, it is not beneficial for every type of environment. It is only good for dynamic changes or when we just want to add or move the resources dynamically. Use of elastic services generally implies all resources in the infrastructure to be elastic. So if we are going for elastic services, It's our responsibility to make it sure that all the resources that we are using in our infrastructure should be elastic. This includes, but not limited to, hardware, software. QoS means quality of service, and other policies, connectivity, and other resources that are used in elastic applications. This may become negative trait where performance of strain applications must have grunted performance. It's depend upon the environment. So if we are going for elasticity, it means it's our responsibility to make it sure that all the resources that we are using in the infrastructure should be elastic. Elastic means they are capable to be grow or shrink automatically or dynamically. If your resources are of static nature, then it is not easiest to be grow or shrink them dynamically. So make it sure that your resources should be elastic. Now see the example. Let us suppose that we are the owner of the company and the database size was smaller in earlier days, and as the business is growing on, the size of database is also increasing. So what I have to do, I just need to send the request to the vendor or a cloud service vendor to scale up the size of database or to add on the database capacity so that we can handle heavy workload. So it's completely different from elasticity, because scalability used to fulfill the static needs, while elasticity used to fulfill the dynamic needs of organization. This is the main difference. Elasticity for dynamic requirement or fulfilling of needs, whereas scalability is for static. Scalability is similar kind of services that will be provided by cloud, where the customer have to pay per use. For both cases, either for elasticity or for scalability, we have to pay per use. How much the services we are using, we have to pay accordingly. So at the end, we can say that scalability useful where the workload remain high and increase statically. Now see, we are discussing about the example of database size grow with this within the growing of workload in organization. So somewhere it is predictable to the owner of the company that we have to grow the size at some time of the database. So we can consider it under the category of scalability. It is not elasticity, because we know that if if I have two departments in my organization, it is predictable to me that max to max I need 10 employees. A little bit I know about this. If I'm growing my organization or my business now from 2 department, it is converted into double, that is 4 department. Again, it is little bit predictable to me how many employees I need and what the size of database I need. Then in that case, I don't go for elasticity. I have to go for scalability, because little bit I know, as I'm the owner of the company, I know how much the size of the database will increase, or how much or how many employees I need more. But if I don't know anything in advance, everything is going on automatically. In that case, I have to go for elasticity, not for scalability. This is elasticity in cloud computing. Within the time, the demand, either it is growing or shrinking. See, in first we have 3, then demand is growing on, then again demand is growing on, shrinking, shrinking, growing, shrinking. It means it's dynamic. Sometime it's growing, sometime it's shrinking. There is no any fixed time period. Now it's growing only, now it's shrinking only. Everything is going dynamically. We know that in case of online shopping, we know that in the month of April, May, June, there is no any much famous festival. So we know that the chances of online shopping is less. But we know that in winter, like on a Christmas, on a New Year, on a Diwali, we know that the shopping chances are more. So in that case, we have to go for scalability, because we know we have some clue, some idea. But if we don't know anything and everything is going or shrinking dynamically, then we have to go for elasticity. Cloud elasticity is one of the popular feature that is associated with horizontal scaling, which allows for resources to be dynamically added or removed when needed. So when we are going for cloud elasticity, we just need to go for scale out solution. Scale out means horizontal scaling, so that we can add or remove the resources dynamically when it is needed. Elasticity is associated with public cloud resources, and it is more common feature that is depend upon or connected with pay per use or pay as you grow services. Pay as you grow services means the more services you are growing or the more services you are demanding, the more you have to pay for this. This means IT manager are not paying for more resources than they are consuming and given time. So IT manager have to pay only for the services they are using and for the time period they are using these services. In virtualized environment, cloud elasticity could include the ability to dynamically deploy new virtual machines or shut down the inactive virtual machines. As we know that elasticity means we can add or remove the resources dynamically. Now, if we have virtualization and we are implementing cloud elasticity in virtualization, it means we can add new virtual machines dynamically, or we can delete or remove inactive or shut down inactive virtual machines when they are not working or when they are not active. It means we can do all the tasks dynamically. A use case that would easily have the need for cloud elasticity would be in the retail with increased seasonal activity. For example, as we have discussed earlier, we know that in a time of festivals, we know that we have more chances to get hits on the web page. But in case of normal months like August, September, March, April, we have less chances to get the hits on the web page. So if we know little bit in advance, then we have to go for scalability. And if nothing is predictable in the future, in advance, we don't know what will be happen in the future. I don't know how many resources I need to add or how many resources I just want to delete. Then in that case, we have to go for scalability, elasticity, because it's dynamic. We can add or move the resources dynamically. So, but before going for either you want to go for elasticity or you want to go for what we said, scalability. So elasticity means we can add or move the resources dynamically according to the requirement. And it's completely depend upon pay as you grow or pay as per use. Now the question is that where elasticity and scalability both cross paths. It's very important to know some cloud services are considered adaptable solutions where both they can go for scalability and elasticity, means they were comfortable with a static environment or dynamic environment. So they allow IT departments to expand or contract their resources and services based on their needs, while also offer pay as you grow to scale for performance and resources needs to meet SLA. So it's very important to know where the elasticity and scalability both are crossing the path. So some of the cloud services providing both. It can go for a scalability or elasticity at a same platform or at a same level. Now most of the IT departments now they can grow or shrink their resources and services depend upon their requirements. What they need to do, they just need to pay for their use. As much we are using the services, the more we have to pay for this. And what we have to meet for SLA, that is service level agreement. SLA stands for service level agreement, and this is one of the type of the agreement between the cloud service provider and the consumer. Consumer means the person who is getting the services from service provider or vendor. Incorporation of both of these capabilities and important considerations for IT managers who are working on constantly changing or who are working on dynamic changes. So do not fall into the sales confusion of services where cloud elasticity and scalability are presented as the same service by public cloud services. So they are differences between elasticity and scalability. It's completely depend upon your business needs, on your business requirements, for which you want to choose. You want to go for elasticity or you want to go for a scalability. Which is the best choice for you is completely depend upon your business requirement. A rule of thumb can help you make that decision. Cloud scalability is delivered more easily in a private cloud environment, where cloud elasticity is delivered more easily in a public cloud environment. So both have different. Scalability is for static environment and it is delivered in private cloud environment, whereas elasticity is delivered in public cloud environment. It is used for a dynamic environment. Turbonomic allows you to effectively manage and optimize both cloud scalability and cloud elasticity. It's not only optimize the infrastructure for performance and efficiency while upholding compliance in an automatic manner. So it keep infrastructure right size for the scalability and elasticity in a real time for on-premises, hybrid and cloud environments. So there is one question that if we are going for either for a cloud elasticity or for a cloud scalability, make it sure that your infrastructure should be capable enough to work with that. It means we are not, if the organization or business is not updated to be scalable or to be elastic, then it's completely useless to be either go for a elasticity or for a scalability. Now next term is cloud scalability. Cloud scalability is basically used to handle the growing workload where the good performance is also needed so that they can work efficiently with the software or applications. Scalability is used in those cases when we want to handle the workload statically, not dynamically. So scalability means I just want to handle the growing workload as my organization is growing on, as the number of employees are growing on. Definitely, my workload is also growing. Now I have to manage such workload in a very efficient manner so that with the growing workload, the performance of workload does not hamper. It could be good enough. So how it is possible? It is possible by using the cloud scalability. Next is types of scalability. First, we have a vertical scalability. Vertical scalability is also known as scale up. In this type of scalability, we increase the power of existing resources in a working environment in upward direction. This is, see, the direction of arrow is upward. It means it's vertically scaling. First, we have our source 1, then upward 2, 3, 4, 5, 6, 7, 8, 9, 10. It means the resources are increasing in a upward direction. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this way, the resources are scaling. It means we are adding the resources, but in a vertical nature. Next type of scalability is horizontal scalability. In this kind of scaling, the resources are added in horizontal row. Now the direction of arrow is from left to right, and this is called horizontal scaling. 1, 2, 3, 4, 5, 6, 7. So in this way, the resources are scaling or growing up. This is diagonal scaling. It is the mixture of both. Either it's growing vertically or it's growing horizontally. Vertically means 1, 2, 3, 4, 5. Again, it's growing up on a upward direction. Again, it's growing up on a from left to right direction. So diagonal scalability is the combination of both horizontal and vertical. We can add resources both on a vertically or horizontally. This is the difference between cloud elasticity and scalability. Cloud elasticity is basically used when we want to meet sudden up and sudden down in the workload for a small period of time. It means when suddenly I need to add up the resources and suddenly I need to remove the resources. Cloud scalability used when I just want to add the resources or delete the resources in a static way. I know in advance how many resources I needed, then we go for scalability. It's growing with the factor, it may be the number of employees, the size of database. If growing, then we have to grow or shrink. Then various factors we can grow or shrink the resources depend upon the performance or number of customers increasing, the size of database is increasing. So we have a lots of factors. Second is that elasticity used for dynamic changes and scalability is used for static changes. Elasticity is used for small companies where workload or demand increase for a specific for some time period and it should be dynamic. Whereas scalability used for some different types of companies where where customer have to grow or shrink statically, not dynamically. It is short-term planning, whereas elasticity is not a long-term planning. It's a short-term planning, and it's only adopted just to deal with unexpected increase in demand or seasonal demand. As we have discussed many times, elasticity is only useful when we don't know in advance how many resources I have to add or how many resources I have to delete. Unexpected increase may be arises, unexpected decrease may be arises. When nothing is expected, nothing is predictable, then we have to go for elasticity. Scalability is a long-term planning. Now it's not a short-term planning, it's a long-term planning, and basically it deals with expected increase. Something is predictable in advance, something is expected, we know something, then we have to go for a scalability. The next topic is capacity planning. Capacity planning seeks a heavy demand. It determines whether the system are working properly, used to measure their performance, determine the user of patterns, and predict the future demand of cloud capacity. So capacity planning means it's very one of the biggest responsibility, that how can we plan the capacity, how can we how we are managing the capacity. So basically why we need to do the capacity planning, because capacity planning determines or predicts whether the system is working properly, or they just need to check for the performance and check for the patterns, or even capacity planning is used to predict some futures demands of cloud capacity. So this also adds an expertise planning for improvement and optimize performance. So by using the planning, we can even improve the performance or even optimize the performance. The main goal of capacity planning is to maintain the workload without improving the efficiency. Tuning of performance and work optimization is not the major target of capacity planners. So when we are planning capacity, tuning of performance and work optimization is not a big deal. Basically, it measures the maximum amount of task it can perform. Capacity planning just want to check the maximum amount of task the system should be capable of to perform. Capacity planning for cloud technology or for a cloud computing offers the system with more latest capabilities that include some challenges over a physical system. So capacity planning means we have to go for the capacity plannings where we can check for the system are working properly or any problem. We can measure the performance, either it is performing or working according to our requirement or business needs. We can see the patterns, even we can predict some future demands of cloud elasticity or cloud capacity. So basically when we are doing the capacity planning, what we need to check, we have to measure the maximum task that the system is able to complete. Capacity planning steps. Now we are going for a capacity planning. We have to follow some steps. First, determine the distinctiveness of the present system. Now we have to determine some different or difference of present system with previous system. Now you have to make a difference what the existing system and what the proposed system is this. If we are designing with the new system, but why we need to do for the new system, and what the problems that we faces in the existing system, and what we have to do some improvement in a new system. Next, determine the working load for different resources, CPU, RAM, network. So we have to determine the workload for all the resources like CPU, like RAM, like network. Next is load the system until it gets overloaded. So you have to put the instructions onto the system until and unless it gets overloaded. And the state what's requiring to uphold acceptable performance. So it means you have to give a workload to the resources at a level, at a state, unless it got overloaded. Predict the future based and older statistical reports and other factors. So you have to predict or make some study of the statistical reports and other factors. Deploy resources to meet the prediction and calculations. Now implement or start working on your resources in a final manner so that we can do the predictions or calculation. And repeat step 1 to 5 as a loop. You have to follow all these steps until or unless you get a good performance. So the task is you have to know the difference between old system and the new system on which we are working. You have to divide the workload for various resources. You have to give the workload or a task to CPU, to RAM, to network. You have to give the task to the system at such level of state until or unless it gets overloaded. You have to read out some older statistical reports and other factors for future analysis. And you have to give the resources to meet the prediction and calculations, and repeat step 1 to 5 until and unless you get the best performance. Next, we have cloud application baseline. The first thing that comes into the mind when we're dealing with business issue is the system capacity or the working load as a measurable quantity over the time, since many developers build their own cloud-based applications and websites based on LAMP. So it means when we are working for business, then first thing that should come into my mind is system capacity. How much capable my system is to handle the workload. Because workload is everything for any business or organization. If your system is slow and not capable to handle the heavy workload, then you have to pay for that. The full form of LAMP is that L stands for Linux, that is an operating system. A stands for Apache, that is Apache Software Foundation web server. M stands for MySQL, that is database server. P stands for PHP, that is hypertext preprocessor. All these four technology are completely open source, and their distribution is different from cloud to cloud. They are we have some other variations of LAMP, like we have OPAMP, OpenBSD, Apache MySQL, PHP, SAMP. We have WAMP. Instead of LAMP, we have a OPAMP, SAMP, WAMP, Windows, Apache MySQL, PHP. So when we go for a business, we just need to know how much my system is capable to handle the workload. It means whether your system is capable to handle the fault tolerance. If any problem arises, if any crashes arises, your system is capable to handle such loss. So we have one term that is called LAMP: Linux, Apache, MySQL, and PHP. Now we have some goals of capacity planner. First goal of capacity planner is to identify significant and important resources. The goal of capacity planner is to identify significant and important resources that have resource ceiling and add more resources to move the restricted access to higher level of demands. Network capacity is one of the hardest factor to resolve, and the performance of network is affected by I/O of the network at the server and network traffic from cloud to ISP, internet service provider. So one of the goal of capacity planner is to find out or to identify the important resources whose scaling is already done. So network capacity is very tough because performance affected when the network services we are going to take, and basically it is affected by IO, input output, when it is connected from cloud to internet service provider. Now capacity planner try to find the solutions to meet future demands by providing some additional capacities so that we can fulfill all these demands. Performance and capacity both are the different attributes of the system. Performance is different and capacity is different. Cloud capacity measures and concerns about how much workload a system can hold. So capacity means how much workload a system can handle. That is called capacity, means capability. How much capable the system is to handle the workload. Whereas performance deals with the rate at which tasks get performed. It means capacity means let us suppose my system is capable of holding or storing 1 TB of data. That is called capacity. Now come to performance means at which rate the task get performed. It perform in a slow manner, in an average manner, or at a fast speed. So capacity and performance both are different. We have next term that is called baseline measurement. Basically we have two parameters or factors. One is page view and second is transaction. Page view means how can we measure the baseline? First we have page view. It means we can measure it by in case of page view we have to see the number of hits on the website. Means how many number of hits you get on your website, and it is basically measured in hits per second. How many people come to your website, access your website, and this will be measured in hits per second. Transaction, that is measured by transaction per second, and transaction means the number of queries the database server complete per second. So we have two baseline measurements, page view and transaction. Page view means how many hits I get on my website, and we just measure it in the terms of hits per second. And next we have a transaction. Transaction means it is measured by transaction per second, and basically how can we calculate it? We can calculate it by using how many queries or requests that should be handled by the database server per second. So we have a page view, second we have a transaction. Next we have a load testing. It is very important. How your system is performing, it is completely done by doing the load testing. We have to test the load on the system so that we can do the analysis of the capacity and performance of the system. It means we need to know, it is known to everyone how much the load should be handled by your computer system, how much it should be capable to process the transactions. So server administrator check for server under load for system matrices to give capacity planner enough information. So by testing the load, we can see how much your system is capable to handle the load. So load testing needs such type of questions. What is the optimum load that system can support? It means we just need to check how much load your system can support, what system blocks the current system and limits the system performance. It means what is your current system and what are the different limitations your system performance have. Can the configuration be altered in the server to use the capacity? It means can we do some modifications on the server side to increase the capacity of the system? How will the server react concerning performance with other server having different characteristics? It means can we compare the two server, because one of the server have different performance characteristics and other of the server have different characteristics. Next is resource ceiling. During load testing, over a certain load for a particular server, the CPU, the RAM, the disk IOs utilization rate rise because do not reach their resource ceiling. Resource ceiling means you have to do the ceiling of the resources like CPU, RAM, disk IO. The network IO reaches its maximum 100% utilization at about 50% of the tested load. It means when we are doing the testing, when we go for load testing, CPU, RAM, disk IO utilization reaches to its maximum limit, that it is 100% utilized, and 50% is only go for tested load. And this factor is current system resource ceiling. Network IO is often a bottleneck in web servers, and this is the why websites prefer to scale out using many low powered servers instead of scaling up with fewer but more powerful services. It means when we go for a load testing, what we have to do, most of if we are getting 100% utilization of CPU, RAM, disk IO, 50% is only go for load testing. So first you have to do the ceiling of resources. You have to give some maximum limit, that is only this part of resources get be utilized during testing. Let's consider a complicated case when data rises in a MySQL database server node to exhibit resource ceiling for either their file caches or the disk IO performance. Let us suppose I want to design a high performance applications. We have to create a large number of, we have a one master table, then we have a number of slave MySQL databases like client tables, and all read operations are performed on a child tables, all write operations are performed on a master MySQL database. A master child database has two competing processes and the same server data sharing of common resources. So it means we are performing write operations on master table or master database, and we are performing a read operation on child database. So read and write to master and child databases, the replication traffic between master database and all slave databases. It means we are repeating the same transaction either for a child or for a master. These type of server reach failure when the amount of write traffic in the form of insert, update, delete operations to be master table overtake the ability of the system to replicate data to slave database data serving select operations. So resource ceiling means when we are working with the master MySQL database, or we have a large number of slave MySQL databases, we are crossing, because we have to perform a insert, delete, update, select many transactions of MySQL either on a master table or on a child table. So when we are doing all these transactions, there will be a chances of failure. To overcome this problem, we have to do the resource ceiling. Next is network capacity. There we have three factors to access the network capacity. One is network traffic to and from the network interface at a server, but it physical or virtual interface. It means first we have to do the network interface at the server level, and that interface either can be physical or virtual. Network traffic from cloud to network interface. Second is from cloud to network interface. Third is from cloud through your ISP to your local network interface. So we have three aspects.